Hello everyone and welcome back. In this video, we're going to be looking at the solution for question 5 and the solution for question 6 of the Mathematics January 2023 paper for CSEC. And we begin by looking at question 5. We have a cumulative frequency curve, which is also called a less than curve. And this curve represents the cumulative frequency for 200 students and the time they took to solve an Olympiad question. So the first part of it asks us to use the cumulative frequency curve to estimate the number of students who took more than 50 minutes to solve the problem. Now, importantly, when you're doing these questions, you need to take some time to look at the scale that you're given, the scale that you're using. So here on our x-axis, our time axis, we have 2 centimeters representing 10. That would mean that each of these tiny lines is representing 1 minute. That's very important to remember. And on our y-axis, we have 1 centimeter representing 20 students. So each tiny line here represents 4 students. That is also important to remember. Now that we have put that in, let's look back at our question. It says the number of students who took more than 50 minutes. Remember, this graph is also called a less than curve, because every time we move to a number on the curve and go across, it tells us that that number of persons, in this case, took less than that amount of time. So the number of students who took less than 50 minutes, took more than 50 minutes. Let's put some color in there so we can see it easily. From 50 minutes, we go to the curve and we go up. You could use a broken line. And from there, we go straight across. Notice that the number that we get right here is 196, but the nature of the curve is a less than curve. So this would mean that 50 students took less than or equal to 196 minutes, at most 196 minutes. So the number of students we want are actually above here. So this 196 isn't the number we want. So to get the number we want, since there are 200 students, we say then 200 minus 196, and that gives us 4 students. So 4 students took that time. The median time taken to solve the problem now, the median, remember, is the halfway point on our graph. And so we look at our total cumulative frequency, it's 200, and find half of that. Half of 200 is 100. And so from 100, we go across on our curve. You can use a broken line, remember. Stop it there, right where it touches the graph, touches the curve, drop it down, and you'll see that it falls right in the middle there. And right in the middle there is telling us, because each of these is 1, so it's 30, 31, 32, 33. That's about 33 and a half. So our median value, or our Q2 value, same thing, is equal to 31.5 minutes. That's very important to remember. And then the probability that a student chosen took at most 28 minutes, which means 28 minutes or less. So the probability that a student took 28 minutes at most. Now, how many students took at most that? Let's go to our graph and go to 28. This is 30, so this would be 28 here. Let's put a straight line there and go up to our curve right there. Then go across, and there you see that that number is 64. So 64 students took at most 28 minutes, so we can write that 68 students. Is it 68 or 64? 64. 64 students took at most that time. So let's correct that. And that's out of 200. So we write that as 32 over 100 in probability. Remember that you need to simplify your answers as much as possible. In this case, we could even write it as a decimal, 0.32, since there's no risk of rounding off and creating an error. So we have finished the first 3 parts. Let's move on to the next part. Here we have a table, and on our table we have the information that would have been used to draw the cumulative frequency curve on the previous page. We have the midpoints all filled in. We have some of the frequencies. We are asked to find two, and we have two numbers here that we need to add in order to find our mean, estimate our mean, which we'll do at the end. But to find these missing numbers, we have to go back to the cumulative frequency curve. Now remember, when you're doing a cumulative frequency, you start off with the first number here, so 12, and then you would say 12 plus this number would give us this number here. So 12 plus what number gives us this number? Well, we don't have this number there, but we can go to our graph and deconstruct the cumulative frequencies. All right, so we can use our graph to find out what the cumulative frequencies were. Let's do that. So remember, in drawing the cumulative frequency curve, we use the upper boundaries. The upper boundaries, and the upper boundary here would be 10.5, there 20.5, 30.5. Just write them in for writing them in sake. So we use these as upper boundaries, and then we use the cumulative frequency as our y value. This is the x, this is the y. That's how we draw it. Now let's go back to our curve and deconstruct them a bit. So 10.5, drawing the line here, you would see that it actually takes us right across to 12. 20.5 takes us across to, that's 36. 30.5 takes us to 80. 40.5 takes us to, and I'm doing all of them because it's important, because I want to make sure that you understand exactly how we are getting the frequencies. So from there, we go across to 164. I'm going to copy these in a moment. 50.5. 50.5 here goes up to 196. And of course, the final one would be 200. So let's go here and write them in. 12, 36, 80, 12, then 36, then 80, then 164, 196, 164, 196, and of course the last one would be 200. So these are the cumulative frequencies. And we would have started with the 12. 12 plus this number would give us this. So we can find what this number is by subtracting 36 minus 12, and that gives us 24. And when we get to this one, would have said 196 minus 64. That gives us 32. And so we have filled in our frequencies. We have replaced the missing frequencies. Having done that, we add our frequencies together. Well, we were told that it's 200 students, but you will realize that when you add this column here, you actually get 198, which pointed to an error in the question. And I'm not sure if, because I didn't see the actual exam paper for this, I got a digital copy of it. And usually, if there's an error in a question, CXC would put out an errata page, which would give the students the updated information. But there's an error right here, where this number should not have been 42, because if you look here to 36 minus 12 gives us 24. 80 minus 36 doesn't give us 42, it actually gives us 44. And that's where the missing 2 would come from. So this number should actually be 42 and not 44. That said, once we find our frequencies, we can multiply the frequency here times the midpoint, and 24 times 15.5. Punch that into your calculator. That, of course, gives 372. And the last one here, 32 times 45.5, would give us 1,456. So having found our missing frequencies and having multiplied frequency by midpoint, we can now sum these. And the sum of fx here, when you add them up, gives us 6,220. And of course, the sum of f would not be 198, but actually 200. So we would have divided for the mean. The mean is the sum of the frequency times the midpoint over the sum of the frequencies. And that, of course, is 6220 divided by 200. And that, of course, gives us 31.1 when we roll it off. If you had gone ahead and used the 42, you would have gotten your mark because that would have been CXC's fault and not your fault. But I'm pointing it out from now, having gone through the question, that there was an actual error here. And the error is that this number should not be 42. It should be 44 based on the cumulative frequency. Moving on to the next part, we have number 6, and number 6 has some measurement in there. In this question, we're using pi as 22/7, and we have something that looks like a track, and we have LM and NP, which are both 98, and we're asked to show there's a diameter here with a semicircle at both ends. We are asked to show that the total length of the running track is 350 meters. Now, in finding the total length of the running track, what we're actually finding is perimeter, and perimeter, as you know, is distance around. So we're going to add this half circle and that half circle plus 98 plus 98, and that would give you the total distance around the track. This half circle and that half circle gives you a full circle. We find that diameter using pi d. So it's pi d plus 98 plus 98. Now pi times diameter here is 22/7 times 49, which we can do some quick calculations with and get a 7 there. 7 times 22 here is 154. So we have 154 plus 98 plus 98. 98 plus 98 is 196. And adding those together, 6 plus 4 is 10. Carry 1, that's 9 plus 1, 10, 15. And carry 1 again. So there we have that the length of our track is indeed 350 meters. Second part of our question says Nathan walks a constant rate of 1.4 meters per second. Calculate the time it will take him to walk 7 laps around the field. Now remember that the field is 350 meters long. So 7 laps around the field is the same thing as 7 times 350. And that gives us a distance of 2,450 meters. So we have our formula. Speed is distance divided by time. His speed is 1.4. So 1.4 is equal to 2,450 divided by time. And doing some algebra here, we have t is equal to 2,450 divided by 1.4. And of course, that gives us 1,750. Remember, we're finding time, and the time is in seconds. So that is in seconds. 1,750 seconds. Verify that on your calculator, of course. Now it says another person, Tafari, runs 1 lap of the track in 68 seconds. Determine the number of laps Tafari can complete in 1 hour running at the same speed. So how many seconds are in an hour? 1 hour is equal to 60 times 60. That's 60 seconds to a minute, and 60 minutes. And he's going to run one lap in 68 seconds. So we can do this calculation, 3,600 divided by 68. And of course, 3,600 divided by 58 lands us at about 52.94, which means approximately 53 laps. So this person, Tafari, can run 53 laps in 1 hour if he runs at the same rate. 1 hour there, 3,600 seconds divided by 68. All right, moving on to the next part. It says Nathan completes running one lap of the track every 72 seconds. So more information, Tafari and Nathan start running at the same time at point L of the track. Each completed a number of laps of the track. Calculate the least number of laps that each will complete before they are both at point L again at the same time. So his speed or the time taken here was 68, which means that Tafari is running a little faster than Nathan is. And so what we need to do is to find the LCM of 72 and 68. I'm not going to go through that process right now, but you can go through and verify it. Check it for yourself. The LCM here for 72 and 68 is 1,224. And when we do the division using the LCM, so 1,224 divided by 72, that would be Nathan. We end up with, for Nathan, we end up with 17. And of course, 1,224 divided by 68 for Tafari, we end up with 18. So Tafari, like we said, is running a bit faster, so he would have completed more laps than Nathan, since he's taking less time to complete the lap. So Tafari completes 18 laps, while Nathan completes 17 laps. And the key to solving this question really is, like I said, just to find the LCM. The LCM would be this, the LCM of 72 and 68. Find that LCM, and once we find it, we divide that LCM by these two numbers, and we end up with the number of laps that each person would have completed. When he would have completed 18 laps and he 17 laps, they'd be both at the same point again. That's it for now. Thank you for watching. And of course, you can visit the website and find more past papers, practice papers as you continue studying and preparing for your exam. Best wishes.